R-var, but it's a different, it's a variable register. But usually they have only one R. You know, when you try to give a register, they have one R, and once you place it, you have to change the value here. Okay, I think it's here. It's 1K. So you have to change the value from 1K to something you wish. But in Multisim, when you have a register, we go to place and components. You see, you have resistance of all the values, 825, 845, and everything. So you can basically choose whatever you need, and then of course you can edit it. If you need, you can edit the value. But the benefit of this is these are real-life component codes. This depicts the one you can find in the market. So when you have a register, say you want 1.0K, so you get this one. But this is the manufacturer code that you can actually find in the market. So what you can do is you can just use like 1206, and you can just put it here. Okay, you can put it here. You know, it looks the same as the others, but the difference is, as I said, when you try to export it to the PCB layout, this may have different shapes. You know, the registers in different thickness, or you know, different power ratings or anything. So you can easily export these things to Altiboard or other PCB layout. So that's the benefit of using a multisim. You can have real-life components placed with your circuit, so it's easy to convert. In PSpice, you just have the schematic, that's all. You cannot convert it to the PCB layout. The next one is that's a huge library. The design is easily transferable. That's what I was saying is Altiboard is another from Multisim. So you can just transfer the design and you can have a real life thing. I think if I show you Altiboard somewhere here, I think I have Altiboard. Okay. So this is an Altiboard. So when you have Altiboard, so this is how it looks like. The software screen looks like. You can either have like this. You see, you can see the designs. When you open Altiboard, it will be automatically converted to something like this, and then you drag and drop whatever you feel like, or you have this like this. You know, the real life it will be. Or sometimes you can have a 3D view. See, on the right you have the PCB layout. On the left, you can actually view how it will look like in real life. So that's what Altiboard does. It takes the schematic from your multisim, it converts it with this design, and then that shows you how it looks in real life. But this thing is not available in PSpice or any OrCAD software. I mean, I haven't found it yet. So that's basically the main comparisons with PSpice. This is, you know, more convenient, more flexible, and it's more versatile, a lot versatile. You can like do anything, almost design anything with this software. Okay, so the next one is these are the analysis techniques that we have. I mean, that we need when we're studying or designing. DC operating point, AC sweep analysis, parametric sweep. So these are the things we actually need to learn. This is why we use Multisim. So the green highlighted ones are the ones we usually need, but I'll be showing that the AC analysis, transient, DC sweep, and parametric. The operating point is just for when you're working with transistors and all. You may want to use that. The other four are the most needed. You just check if you're varying the frequency, what happens. If you're varying the voltage, what happens. If you're varying the capacitance, what happens, or the resistance. So you these are basically the analysis techniques we're using. So there's just some labeling how Multisim is. This is the main interface, menu bar, toolbox, active tab, and everything. So I think you have already seen this one. The next is on toolbar, standard toolbar. This is this. I think these are in the handouts I have given. So you can find those, and you can take the soft copy afterwards. So this was basically an introduction to what Multisim and PSpice, what it is. So now we'll go and design something in Multisim and see what actually happens and how it is to work with Multisim. I guess we get out of, this PowerPoint slides. I think you can all see this in the slides. So let's close PSpice. Let's minimize it and let's do it out. So this is your blank page for this one. Let's delete. Okay, so it's deleted. So this is the page you have to work in. It's just open and you can start. Not like PSpice, you have to name the file first or something like that. So let's start. To start with designing, the most convenient way is to go to place here. I think you can see. You go to place. You go to place and components. So you get all the list of components here. You can get all the components here. So there's relay, connectors, whatever there is, you can work with. Everything is just available here. There is the group, the database is master database. Sometimes you can use a corporate database, but then I think you need to buy a license or something. Then you get their specific components. You can even create your own components with your own specifications. That should be the user database. But the master database is the one that comes with Multisim. And here you get all all the components, like every kind of components under this thing. So this is select all groups I have. So you have sources, that is basically the batteries and voltage source, multipliers, differentiator, and everything. Actually, I think these are the things like differentiator, divider. I think this is what in your assignment they have all these things like adding and subtracting. So these are those things, but you have to design it from the basic. Actually, you can't use this, what should I say, the ICs that automatically does it for you. You have to design it from the scratch. Then you have diodes, Zener diode, Schottky diode, and everything. Whatever you name it, you have it. So let's start with the basic. Thing that we usually do. We have a power source. Let's have DC power. Okay, let's have a DC, but that's just a normal battery. And then let's have some resistors. Let's have this one. Okay, I pass. I give again okay, then I pass. And now I need the ground. So I go to source. I type G. Okay, that will give me the ground. So I bring the ground. Okay, and I just put it here. So I have the ground. Okay. So I have the ground, I have my batteries. Now what I need to do is I need to connect this thing and see how they behave and all. So to connect, bring the mouse pointer to, just the tip of the other component. Have a click here and you can it starts. So if you want an anchor here, you can just click and it will stick there. So anywhere you move, it will just be there. You just click here and it will be fixed to that point. Now from here you can bring to this. So these two are now connected. This is just connected, nothing like PSpice, sometimes they don't connect and all. So in a similar way, you connect and you bring here. You connect this, you bring until here. You connect to ground, it's done. And this end you connect here, and I think it's connected. Okay, so basically this is our circuit and it's connected as we can see. Now we can run different kinds of analysis like DC analysis, AC analysis, and whatever we want. AC will not apply here because we have a DC source. So that's how. Now, can you guys just try making this circuit? Just let's check out. Okay, so I think everyone has done it. So once we have constructed the circuit, we can do any analysis we want. But in PSpice, you notice one thing. You click, there's a V and I icon. Something here, V and I. When you click on that, you can see the current and voltages, with the wires. In everywhere, how much current is flowing or how much voltage is there. In Multisim, if you want to do something like that, you have to go to your right. There is a yellow icon. It's measurement probe. It's called measurement probe. I think you can see it there. Okay, it's measurement probe there. So what you have to do is you have to get this measurement probe and hold on. Okay. Okay, you have the measurement probe, and you want to put it here. So you just click here, and you have the probe. This is probe 1. So this thing will give you the voltage and everything here with RMS voltage, peak to peak, and DC, everything. You can get everything. In PSpice, you only get the voltage and only the current. Here you get everything actually, whatever is happening. So if you want to get values here, if you just click the play button, and it gives the voltage. Since it's a DC, it's not varying. So you can see on the top there is a V is 6V, and there is 6V. The current is 7.81 mA, and IDC is 7.81 mA. So you can see these two resistors are identical, 768, 768. And the voltage here is 6V, and the source is 12V. So basically it divides into two because it's identical resistors. And as you can see, it's like 6V over there. So it's pretty understandable that, yeah, this is working. This gives us the voltage there. If you want to see the current, you just divide 12 by 768. So let's just see how it works. Okay, we have 768 plus 768. Okay, it's 1536. So let's clear it, 1536. So when you divide 12 by 1536, you get 0.007825, and that would be our 7.81 milliampere. So yeah, you can see the current, it shows the current in the circuit, it shows the voltage in exactly that point, and everything else. So you can test it actually if you have like this. So you can place another probe here. You have a probe, you put it here. You just put it here, and you see, this thing is showing 0 because this is grounded. This part is grounded. This part is grounded. So this shows the voltage is 0V, but current is 7.81. So 7.81 milliampere is flowing in the whole circuit, but you can see the voltage is different points. So that's how you see everything. And if you want to print this circuit, I think it prints with, if you give